Hello, my name is Brian Sam-Bodden. I work at the Redis Labs education team as a developer advocate.
Hi, my name is Josh Long, and I work on the Spring team.
Redis is a fast, scalable, multi-model database that powers experiences at world-class organizations like Microsoft, MasterCard, Stack Overflow, Twitter, and GitHub.
And Spring is an application framework that's an opinionated approach to the JVM ecosystem. It's the app development sensation that's sweeping nations, and it powers experiences at Alibaba, Amazon, eBay, Apple, and Netflix.
In short, if you're on the internet, you're using technology powered by Spring and Redis.
These technologies are awesome because they focus on three major concerns: ubiquity, performance, and developer happiness.
And in this presentation, we're going to be looking at opportunities that make Spring and Redis a very dynamic duo indeed.
In this first section, we're going to look at how to build a Spring Boot application that incorporates Redis, starting at start.spring.io. We're going to take a look at the foundational support in Spring Data Redis. We're going to look at support for distributed lists and for geospatial queries with Spring Data Redis as well. And of course, from there, we'll see how to get an application packaged up and ready to use in production. Let's go create a new application at start.spring.io. We're going to add the Reactive Redis support. We're going to add Lombok. And we're going to add the Spring Native experimental support. Let's go ahead and hit generate. That'll give us a zip file that we can open up in our IDE. In this application, we'll demonstrate a few key concepts. What you need to know is that Spring Boot will automatically instantiate a Redis connection factory that we can use to talk to it. You can control how it connects to the Redis host and port and so on by specifying properties in application.properties. For our purposes, I have Redis on the local machine on localhost at the default host and port, so I don't really need to do anything here, but it'll work. I'm going to create a few different examples, a few different objects that get run when the application starts up. The first one will demonstrate just interacting with some of the basic types that you get with Redis. Remember, Redis, at the end of the day, is a distributed data structure server. So we're going to use something called a template. A template is an object that makes it trivial to do certain things with a given API, a given abstraction, in this case, a service, the Redis database. We're going to create a template that writes data to a list. Now, you can see we've injected this template as a collaborating object for this object that we're creating of type application runner. When Spring starts up, it invokes each method annotated with @bean, returns the value. So here I can see that I've got a lot of different template objects for geography, for hashes, for lists, for keys and values, for streams, for z-sets, etc. For our purposes, let's start with ops for list. That'll give us an object of type reactive list operations. Basically, it's a reactive list template. List template. And then we're going to write some data to that list. And this list will be given a name, and we're just going to call this the Spring team, or just some members of the Spring team. I'm going to now write some data to this list using reactive APIs. Now, reactive means it's not blocking, it's asynchronous, and it's eventually going to resolve, but it's not guaranteed that it resolves immediately, right? This is great for describing asynchronous, unbounded streams of data. And I'll give it the key, which is a list name. And here I'm just going to add some people that are on the Spring team. Not everybody, but just a few of them. And that'll do it. That'll actually give us a bunch of records that have been added to the list there into the database. I can store the asynchronous return value that represents that operation as a variable. And then I want to get the data. After I've written it, I want to then act on the data. So I'm going to say push, and then I'm going to say then many, and I'm going to then run operations. I'm going to say list template dot left pop, and I'll give it the list name. And I'm going to log the first thing that comes out. It's going to pop out one value of the list. So I'll say on next result, and I'll just log it out. Result. All right, and then I'll do a then many, and I'll say list template dot left pop again, and I'm expecting now to get the second value from the right, right? So here, I'll left pop the list name one more time, and I'll print that result again. So I should see the last two names in this list, and then finally I'm going to force the resolution of the entire thing, right? So remember, I've got a bunch of asynchronous things that need to happen. I'm going to force their evaluation there. And so we'll see the two names at the very end, Violetta first and then Olga, get printed on the console there. So that's one interaction, but there's a lot of different kinds of data structures, a lot of different kinds of operations that are supported by Redis out of the box, another of which is geographical indexes. So great for geographical queries. This is one of those things where you could use something like MongoDB, but if you've already got Redis, then use this. Or if you have Redis, then maybe you don't need Postgres' PostGIS or something like that. Application runner, geography, and here again I'll inject a collaborating object of type Redis template. And I need the geographical options, so I'll create a geo template equals template.ops for geo. And here I'm going to write a bunch of points, a bunch of geographical points on a map or a plane. And now I've got my points, and I'm going to take each one of those and write it to the geographical template. So I'll create a stream out of the entries in the map, a reactive stream. And for each entry, I'm going to turn it into a write. Now I need to give it a key and then the point. I need to give it a key, then the point itself. So in order to do that, I need to create a key, and these are all points in Italy. So I'll use the key here, Sicily. So Sicily will be the key, and the next thing that I care about is the point itself, which is e.getValue, and then e.getKey. All right. Then I'll get all the results. And I'm going to do a query. And I'm going to query for everything within a certain geographical boundary, in this case a circle. And that circle I'll define as a point and then a radius from that point. That'll give me a bunch of results that I can work with. These are geo results. But I want to actually map the results first. So I'll given a geo result, I'll say give me the content, which is the geolocation. And then for each one of those, I'm going to take the result and get the name, which is the name of the location, the string name that we gave it. And then finally I'm going to print out each result that comes back. And subscribe. Now let's see what happens. We've got our geography and we've got our list. So we expect to see 2 items from the list and whatever point matches our query. Okay, it worked. So we got Palermo, which is the result that matches our query. And then we got Violetta and Olga at the very end of the list. We've created a very simple application here. We've got an application that starts up very quickly. We can use it like this, but we can actually do better. We can actually turn this into a native image, a GraalVM native image. And this is going to be a nice fit because it vastly improves the startup time, going from 0.4 seconds down to less than 1/10 of a second. Can you believe it? It finished. I thought I would never finish. That was an adventure. Here we are, and the build has actually completed. We can start the application, and it starts up, and in record time too. It started up in 34 milliseconds. So 34 1,000ths of a second. Amazing. You knew this section was coming. Of course you did. It had to happen. It's Redis. Redis is famously a key value store among its many, many other talents. It's an amazing fit for caching. Let's take a look at caching with Redis. Redis is a great fit for high throughput caching and memoization. That is to say, we can remember any long-running computations and then return those on subsequent accesses directly from cache. This prevents unnecessary duplicative effort. It's also a great way to speed up your application's behavior and response time and availability. Spring provides a cache manager abstraction that we're going to use here to support caching in our application. So let's create a new application here using Redis, and we're going to use Lombok, and we're going to use the cache abstraction. Let's go ahead and open up our application, and we're going to create a very simple service here called the expensive service. And this service is going to do a computation that produces a response, and the response is just going to be an object, not because it needs to be, but because I want to show you that it can work. So we're going to say private final string message, and we're going to use Lombok to make short work of the creation of getters, setters, toString equals hash code. This object is going to be persisted inside of Redis, so we need to make sure it's serializable. And we're going to create a endpoint that returns an object of type response that does something expensive. Make sure that this endpoint is marked as cacheable, and you can give it a name here. This will feed into what is used for the key, for example, expensive. Let's use this, this little bit of execution code here a couple times in an application runner when the application starts up. It's taking its time. There you go. So the first time it took 10 seconds and some change. The second time it took 7 milliseconds to get that response. And yet you can see we got the exact same response. There is so much more beyond what we're showing here, of course, including support for expiring cached values and for cached values based on selected parameters. There's also good support and integration for the JavaX cache standard as well.
Hey, what good is great data if you can't find what you're looking for? In this section, we're going to add search functionality to a Spring Boot application. No, you don't need Elasticsearch. Instead, we're going to be using Redis Search, the newest and fastest member of the search engine world. In order to use Redis Search, we need to have a Redis instance that actually has Redis Search installed. To simplify things, I provided a Docker Compose YAML file that we can use to launch a Docker that contains all modules pre-installed. As you can see, it has Redis AI, Search, Graph, Time Series, JSON, Bloom, and Gears. Launching that, we can now run the Redis CLI. We can do a module list, and we can see the modules that have been installed and their versions. I also like to run a Redis CLI in monitor mode as we work with any framework so we can see what commands are being issued against Redis. With a properly configured Redis instance, now we can take a look at the application skeleton. And the first thing I want to highlight is dependencies. We are going to use the JRedis Search client library, which depends on the Redis low-level driver. In the POM file, I've added an exclusion for the latest driver since we are using Redis. And I'm also explicitly adding the Redis dependency. We also include the JRedis search library, and we are using Java Faker to create some fake data for our test. Okay, so now we can take a look at the main application class, and that would be Redis Search Application.java. The first thing I want to highlight is our Redis connection factory that returns Redis-based connections. We also have a Redis template, which is a gateway to Redis commands. And it's configured to use the Redis connection factory and also set to serialize keys and values using the string Redis serializer. Okay, so let's take a look at the domain for our application. We have a super simple domain. I kept the domain classes in the same Java file to keep it simple and contained. We have two classes, articles and authors. Authors have a full name and an ID. They're annotated with the @data Lombok annotation and the all-args constructor annotation. So they're fully qualified POJOs. And the start of the show is the Redis hash annotation. The Redis hash annotation is part of Spring Data Redis, and like other Spring Data annotations, it allows you to map a class to a storage entity. In this case, it maps a Java class to a Redis hash. It supports all the most of the data annotations inside of the class. For example, @ID, it's supported, and it will create auto-generated IDs for our Redis hashes. Down below, we have the article class that also has an ID, a title, and a price. And it has a collection of authors in a set annotated with the @reference annotation, which means that we'll be keeping the IDs of the authors associated with an article in place. We also have our two Spring Data Redis repositories. The article repository, which extends the CRUD repository for articles with a string primary key. And similarly, we have the author repository that extends the CRUD repository also for authors with a string primary key. All right, so let's talk about our fake data generation. Outside of the class, I've added an article type enum for the types of articles that we'll be generating. Now, back in the main application, we have a map to assist in the generation of fake article titles. I have 4 article title templates for each of the article types, using printf style format strings to include 2 random words or sentences that will be generated using the faker gem, the faker jar. The get fake article title below, this method takes an instance of the Java Faker and randomly picks an article category. Then it uses some of the different Java Faker methods to generate the 2 parameters needed to create a concrete title. We have the make me some data method, which returns a command line runner and is annotated with the bean annotation. This method takes an article repo, an author repo, the Redis template, and also the Redis connection factory. Inside of it, the first thing that we do it so we don't repeat the data loading procedure, it's check whether the article repo has any items in it. Inside of it, we instantiate a faker, and then in a loop, we create 250 new authors using the author constructor, and then saving them to the author repo. Once we have those 250 authors created, we're going to loop 2,500 times and create 2,500 articles. We get the title from the get fake article title method we created previously. And then we're going to loop asking for the article title again until we get a unique value. So we're going to have this hash called titles, where we're going to keep the titles that we have used so far, and that way we can avoid duplicate titles in our data. So down below, I have the article creation. Notice that I'm using also Faker to create a fake price. And then for each article created, we're going to pick a random number of authors, and we're going to use the Redis template operations for set to get a random ID for an author so we can assign some authors to each one of our articles. Once we have all that in place, we're going to save the articles to the repository, and we should be ready to work on creating our search indexes. Okay, so now we can proceed with the creation of our search index. And I'm going to start by creating a search index name variable that's going to contain the name of our search index. And I'm going to call it article IDX. Then in a try with resources block, we're going to instantiate a new Redis search client, passing the search index name that we just created, the connection factory's host name, and the connection factory's port. Inside of that block, I'm going to create a schema. In our schema, it's going to determine which fields the search engine will be indexing. And we're going to add a sortable text field for the article's title. The default weight, it's 1. And we will also add a sortable numeric field for the price of the article. All right. With that in place, the other thing that we need to do is now create a definition for our index. So given the schema, we can now create a definition. In our index definition, we'll take the prefix of the hashes that we want to index. In our case, we're going to index the article hashes, which are prefixed with the name of the article class. So I'm going to create a string format in here that is going to basically take the name of the class and add a colon at the end, which is the prefix for our classes, for our hashes. And then in here, we want to take the article class and grab its name. All right. Okay, so now that we have one too many parentheses, now we have a definition for our index. We can invoke the create index method on the client, passing the schema, and we're going to pass the default set of options. So the client class has an index definition or index options class, which provides a default options for our index. And on those default options, we're going to set the definition that we just created. So therefore, we get the default options plus our specific definitions. So this should be enough to create an index for our articles for the title and price fields. Also, if this block executes and the index has already been created, we're going to get an exception. So I'm going to catch that Redis data exception, let's call it JDE, and completely ignore it because that just means that we have already created the index. In place, we can implement our full text search. So to do so, again, I am going to, in a try with resources block, instantiate a Redis search client. And once again, I pass the name of the index, articles-idx. Inside of the block, I'm going to create a new query. And the query simply takes as a parameter the string query that's being passed to our controller method. Then I'm going to check if the min price has been passed and also the max price. So if both of those are provided, and let's check for -1, which is the default value we provided. And if they're not -1, we're going to assume that they want to filter by price. So I'm going to add a filter to my query. And to do so, we need to create a new numeric filter. And it's going to be filter on the price property. And all we need to do is pass the min and max prices. So I'm going to pass the min price and the max price. And that should be enough to actually filter our query. Then we also are going to tell the query what we want back. So we're going to set the return fields to be the title and the price. And that's return fields. And now that we have that in place, we're simply going to return the client's the result from calling the search method, passing our query object that we just created. And this return, obviously, it should be inside of our try with resources block. And now we should be cooking with fire. So with our search method implemented, now I've already started the server and watch all the data load and the index be created. It takes just a few seconds. And now we can test our method on a browser. So I'm going to go to our localhost 8080. Our article lives under, our method lives under API articles, search, and let's pass a query like, let's say, lion, because I know we have some fake data that generates animals. And if we hit that, you can see that we get 18 total results in articles like teacher see lion how to pilot a TU 160. That'll be fun to watch. We can also pass a min price. So let's pass a min price of, let's see, we have 381, let's say between $10 and max price of $20. And once again, let's double check. We call the parameters min price and max price. All right. So we should be able to do that. And now you can see that our search results narrow to use a single one, price of $10.81. How to cook a caprese salad with sea lion. That sounds disgusting. All right, and that is a full text search implementation over Redis hashes in Spring Boot.
We're at the end of our time together, but not the end of our journey.
Hopefully you have gathered that Spring and Redis go together like peanut butter and jelly.